everybody. We're going to be talking today about headless cloud services, and then we're going to go back in time and talk about the mainframe, which may be cool again in the age of AI. And then finally, we're going to talk about, is FinOps going to be embedded into software engineering practices? I'm Mike Vizard, and you're watching Techstrong. All right, folks, we're back and we got a full house today. We're going to start with Mitch Ashley, who joins us once again from his perch in Denver. Mitch, how you doing?
Always good to join you and the gang here.
All right. Then we have Paul Nashawaty, our resident expert on all things application development. Paul, how are you?
Great to be here.
And Paul joins us from the Futurum Group, along with Steven Dickens, who's also from the Futurum Group, where he's a chief technology advisor and an expert on all things cloud and mainframe. Steven, welcome to the show.
Thank you. Great to be here as always.
And then finally, we have Amanda Rosani, editor for Techstrong.ai and Digital CXO, and of course, Techstrong ITSM. So, she has a full plate every day. And so we appreciate her taking time out to be with us. Amanda, how you doing?
Doing well. Thank you.
All right, let's jump into this. There is a story over on Techstrong.ai talking about how this shift to AI will further advance this notion of headless cloud services. The idea here is that I'm just going to invoke APIs to consume the resources I need, and I might not be as tied to various cloud service providers as I have been in the past. Steven, this is not necessarily a new idea, but let's start with you a little bit on this. Is this feasible? Is this something you've seen before, and will AI kind of drive it a little bit more aggressively in your mind?
So is headless the new serverless?
It's the new lights out data center.
Is that what we're calling it these days? No, I mean, all joking aside, Mike, I think there's a reason why we have a podcast every week on the Futurum Group called Infrastructure Matters. Whenever I hear the phrase serverless, I ask what server it runs on, just to tweak the people like Paul who don't worry about infrastructure. I think headless for me just means that somebody in a development team doesn't want to dirty their hands thinking about the infrastructure that it runs on. Infrastructure does matter. Non-functional requirements like performance, availability, security, scalability, sovereignty all matter. And where that infrastructure resides is becoming increasingly crucial. So whether it's headless, whether it's serverless, I think there's always going to be a tension between the development team, who genuinely don't care where this stuff runs, and the operations team that's got to secure and make sure this stuff doesn't go bump in the middle of the night. So I think this is just, for me, yet another sort of go round on that tension.
I don't know, Paul, it sounded to me like Steven was giving you the back of his hand a little bit there, but API...
It would be the first time, would it, Paul?
Yeah, I mean, I've kind of grown accustomed to doing that, working with Steven on that. But basically, I think the approach that I will kind of piggyback off what Steven's saying, I shockingly agree with Steven this time on the fact that from a developer perspective and from a DevOps perspective, the business objectives have changed, over the years. It used to be a heavy emphasis on making sure infrastructure is up, making sure SLAs are up and running. So you have, 5 nines or greater. So you have planned downtime and such. But really what I'm finding from the business logic side, from the developer op and the DevOps and the side up and platform engineering side, it's really not about SLAs anymore. It's about SLOs. It's about service level objectives. It's about making sure that your application's up and running, because you can have an infrastructure that's up and running and working. But if your applications are down, you're still down. So it's plain and simple, right? So it's about the operational side of the business. Now, I want to come back, Mike, to your comment about headless. I was having a little bit of deja vu. I worked in the DXP space, in the CMS space for a while throughout my career. And we moved to a headless DXP, a digital experience platform approach, which is very similar to what we're talking about here, which is basically using APIs in order to connect to data. I view this as, from a developer perspective and from a DevOps perspective, as a bridging the gap between old and new. Whenever we talk about application modernization, we talk about the fact that some applications just don't need to be refactored. Some applications stay in their heritage state because that's where they're optimal. And that might be running on a monolithic infrastructure or an environment or a cloud environment and such. But new systems of engagement will use APIs in order to access those systems of record. And those heritage applications become systems of record, where modernized applications in the front end will use a kind of a quote headless approach to attach to those data sets to give a new, fresh experience to those applications in that data set. We're seeing that a lot with LLMs and AI. We're seeing that a lot with production applications, but we're seeing that across the board in the SDLC overall. So that's where my head goes. I think that the one caution I would caution the audience here, it gets incredibly expensive when you start making all these API calls. But that's a whole different conversation.
I'm gonna thread right down the middle of the two gentlemen here. So I do think it's all about APIs, because it's about dynamic infrastructure, which can be headless or not, whatever you want it to be. Serverless is actually kind of its own, at least in terms of the Lambda kind of services. But I think we're moving past I have one tool to do this kind of automation, one tool to do this kind of monitoring, one tool to do this kind of provisioning. When I want to set things up from a platform engineering console, if you will, or portal, I want to provision in my VMware environment. I want it to set it up in my cloud environment. I want it to load whatever appropriate images of operating system, Kubernetes, containers, all of the configurations that are part of what I need to use as a platform engineer, operations person, or developer. So it's all about the programmability of the infrastructure and being able to automate it across domains as well as across tools. That to me is what we're driving towards. Sometimes it doesn't always feel like it, but we're getting closer and closer to that world.
I think Mitch. Go ahead. I'm sorry.
Well, I just think it takes a hybrid approach. And because the more APIs, also you have to take into consideration keeping track of all the APIs and managing all those as well. So I think it takes a hybrid approach.
I don't think it's going to be easy, and I don't think it's going to happen tomorrow, but I agree with Mitch. We are moving down the path towards, if I put APIs in front of infrastructure and I'm programmably calling that, well, I got news for you. That makes the infrastructure behind it disposable. And for that matter, the infrastructure that AWS already provides is kind of disposable. They don't tell you when they're upgrading their infrastructure underneath those VMs that they're providing. They just tell you that they got a faster one that's available, and it's underneath the API you have. So
I think it's fungible, Mike, not disposable. In other words, I can do what I want with those resources.
I'm going to jump in and say I 100% disagree. So depending on the application and the non-functional requirements of that application, you do care about the underlying infrastructure. If my Netflix is down, I'll just go and watch HBO Max. If my core banking is down and I can't get access to my cash, then there'll be a run on the bank. A nationally defined critical piece of infrastructure will start to get attention, and the economy will start to unravel. If you can't use your Visa card because the core infrastructure is down, then you're going to have trouble. So there's a degree here of what infrastructure is and how fungible it is. Some stuff has to run 8 nines, 9 nines, and has to be basically always available. Other stuff, if it's not there, okay, I don't mind.
Yeah, Steven, look, I agree with you. I think without being overly dramatic about the infrastructure, I know that those use cases certainly matter. I think that the kind of the spirit of the comment that Mike was making is more about however you architect your underlying infrastructure would accommodate your application's needs. You're spot on. You have to have performance, connectivity, latency issues, all sorts of things that kind of make things work. But that is implied that it works. And if it doesn't work on one architecture, it needs to be transparently moving over to another, right? And that to your point, the application needs to be properly, have the resources available to it. But I also think when we look at releasing and code, again, I'm a strong advocate of this because of the data that we have. When organizations are pivoting to releasing code on an hourly basis, the days of putting a help desk ticket in and waiting for things to change in the back end are long since gone, right? That has to be a self-service model for an architecture, an infrastructure that's available to the business logic above. And it has to be dynamically adjustable. So I don't think it doesn't, quote, matter. I think it needs to be architected appropriately to fit the needs of the business.
Mm-hmm.
I will disagree with my learned colleague, Steven, one more time. Servers crash all the time and nobody knows anything about it. And Netflix has servers that burn out and nobody knows anything about it because the software calls are rerouted to other APIs and the whole system is designed to accommodate that. And as that becomes more and more common, more enterprises are going to have a similar mindset.
So Mike, Azure Central had a 14-hour outage a few weeks back. Google had an outage. When the public cloud operates at 3 nines SLA, if you have an outage in a quarter, typically your contractual situation is they'll give you 10% of your bill back. Do you want to know what 3 nines means from an availability point of view? It means you're going to be down 8.77 hours a year.
It means
you don't get to pick when those 8.77 hours are. They just randomly happen. If that randomly happens on Black Friday and you're Walmart or Best Buy, that might be a problem.
I would say that we're going to reroute those calls over to Azure, which is not likely to be down the same time as Google's.
If it's in the same data center, Mike.
It doesn't have to be in the same data center. My app can be redundant and structured to make API calls across different services.
Why does the European Union put in place legislation called DORA? Why did the UK this past week declare data centers as national critical infrastructure? Stuff happens at the infrastructure level that creates outages that businesses can't survive from. Not everything needs to be that way, but in this nice fluffy world of the cloud where magic pixie dust just ensures servers are up, you've got to be more pragmatic than that. And just saying, it's in another availability zone isn't a good enough answer.
I think it's about also architecting it where you can, because some applications are not this way. It's, can you architect it so that you've got some workload portability, wherever that is, same data center, different data center from the same provider. To your point, Steven, you might be fixed, and this is where you have to run because of whatever regulation. And so you're going to architect based on that, right? That's your constraints. Whereas another place, I've got 3 locations I can run in the U.S., East, West, and Midwest, or whatever it might be. But can I make my workloads portable? So if I do have an outage somewhere significant enough that I want to respin up more resources in another data center, that's I think what we're saying is it depends on the situation, right? You've got constraints that you're working with. And in some cases, this is my data center. This is all I'm working in is that room over there down the hall. And that's where all my stuff is. And that's what I've got to live with versus I've got to work in this data center in the cloud or these providers in these locations.
Yeah, Mitch, to add data to what you just said, I agree with you. Our data sets from our research shows that 20% of respondents view application portability as critical to their environment. 67% say it's very important. Look, we're all in, I think, violent agreement here. I think the thing that's interesting is the biggest factor for HA and BC configurations for applications, whether it's portability or availability or across availability zones and such, it's not cost effective to do that for every application. So you can absolutely architect a completely redundant environment, but nobody has the budget to do that. So that's where it runs into the critical applications maybe, but I would say that the entire infrastructure is not completely redundant.
Business critical applications, sure.
My sort of takeaway is not enough people think about recovery point and recovery time objectives. If those need to be architected as near to zero as possible, you're going to have to think about different architectures. There's a scale and a continuum. There's lots of things that can survive with long recovery point and long recovery time. And there's things that can't survive with any of either. That's a long continuum. And it's very, very expensive at zero. And you can throw applications up on the public cloud really cheaply and not architect for availability. You just got to start with what your recovery point and recovery time objective is, and then just plan an architect accordingly.
So I'll agree with Steven on the issue as described for availability in monolithic applications is true. We're not there. I think as we look at more modern applications with microservices, we can architect some redundancy into the system and we can get to a headless model. The question I would ask Paul then is, is this an argument for re-architecting monolithic applications and turning them more into microservices, or is that a bridge too far?
All right, so it would be wrong if I didn't say it depends, because everything it depends, right? So I think that obviously refactoring heritage architectures or heritage applications into microservices and containerization is a desired state for many businesses for a number of reasons. Whether it's portability, as we just talked about, or if it's the flexibility of cloud elasticity, of burst capacity, management of the application. There's a slew of things that you can kind of talk about. But one of the big factors that organizations typically overlook is sometimes refactoring doesn't give you any advantage, except one with the asterisk. Sometimes refactoring doesn't give you any advantage, so they can encapsulate that heritage application to a VM, make it cloud ready, stick it in the cloud, and it's available, right? The problem is a lot of times when those applications are not refactored, it does open up a security hole. A lot of those applications that are not refactored, even though you may get the same performance after refactoring, and so what's the point of doing it? The point is you now have reduced your security vulnerabilities, and that's a challenge that a lot of heritage applications will have, as we all know. I think that if you look at it, if you're looking for availability, if you're looking for that portability, if you're looking for that architecture that allows for that flexibility, refactoring into a cloud native state, so you can go from one of the hyperscalers to an on-prem cloud to an edge location, sure, that's fine. But the other factor comes into play is, what do you gain if that's your number one thing, is the portability piece, fine. But what do you gain on the other side? Do you gain performance, or do you lose performance by going to microservices? And that's where a lot of companies need to really look at and understand what's going on with their heritage environments before they take that plunge into it.
Mike, I suppose I don't accept the premise of what you're saying, that monolithic applications are bad. Netflix went monolithic, microservices, and back to monolithic. Certain applications are better as monoliths. Depending on what your performance criteria is, your availability, your scalability, looking at those non-functional requirements, there is scenarios where monolithic applications are better than microservices. Those might not be the mainstream. They may not be the most by volume. They may not be the sexiest. But there is scenarios where monolithic applications are better than microservices.
I think if you put an API in front of that monolithic application, you got a big-ass microservice. So there you go.
Or lots of them.
So you say tomato, I say tomato. I mean, I mean, the interesting case of Netflix has been through this journey over the last 5 years. They blogged about it. They took their core streaming application, got on the bandwagon of microservices, and have now taken it back to a monolith for performance reasons. I'm not saying that every application should be a monolith, but I'm saying they have their usages.
I will concede the point that microservices are harder to manage and build and maintain, but the benefits of availability may outweigh those issues if you have the right team in place.
So, Mike, if I told you that your Visa credit card application, that your Visa transactions are processed on a monolithic application and there's not been a second of planned or unplanned outage in the last 30 years, would you take that disproves what you just said?
I would say that Visa might often be the exception, given the amount of outages that we see all the time across all kinds of application environments. So,
when was the last time who do you bank with, Mike?
I bank with Citi.
What's your bank account number?
When was the last time Citi went down?
I don't know. I don't monitor it 24/7, so I don't know.
I can't remember a Wall Street Journal headline saying that Citi went down.
And this may be because they have redundant infrastructure, that they built an application that takes advantage of that.
Or it could be that their core banking service runs on a mainframe.
Could be.
Let me interject in the Steven. There are applications where the scale, the volume of what's happening with those applications, credit card transactions, video streaming, right? It isn't, we're doing 10 of them. We're doing thousands of them a minute, tens of thousands, maybe hundreds of thousands in a constant rate. That kind architecting for that kind of an application, because if it goes down, you're talking about millions of dollars per minute that potentially is lost, right? So you're over at that scale you're talking about, zero downtime.
Airline systems like Sabre, Swift payment systems in the banking sector, core banking applications. I'm talking about probably the 1% edge cases. And Mike, you're probably talking about the 99% of the rest. I'm just saying that it isn't zero. There is a scale. Nobody talks about core banking applications. When Barclays went down in 2009, it was front page news. The chairman of the Bank of England calls the chairman of Barclays Bank within 45 minutes and go, "Have we got a problem? Are you guys okay?" There's different applications and they need to be architected differently on different infrastructures.
And I can tell you, growing up in the banking world, when we were designing new banking systems, it was all about transaction per second. It still is, right? And now it's also availability and everything else. It's kind of like the air traffic control system and the airline control programming. It's still around. ACP is still around because it's high volume and it's necessary for, reps at those stations in the airport to be able to take your transaction. There are some things that are kind of over the top in terms of they're just at that maximum point and they're going to run, 40% above full throttle all the time and redlining. That's just the way it works. Now, that's
we're not done arguing just yet, but we're kind of out of time on this particular topic. But we'll be back to have a more spirited conversation about mainframes. We'll be back.
In a world where every line of code powers the future, every keystroke can introduce new threats. As software evolves, so must security. It's time to rethink how we protect our digital world. Join the leaders in DevSecOps and AI at the OpenText DevSecOps Virtual Summit on September 24th. Discover how innovation is transforming software delivery, faster, more secure, and smarter. From AI-driven security to the truth behind cloud security, get the insights that will keep you ahead of the curve. Don't just watch the future unfold. Be part of it. Register now and secure your place in tomorrow's world.
All right, folks, we're back and we're talking about mainframes as promised. There's a new survey from Kyndryl. It's up on Techstrong.ai. Talking about how, well, people seemed optimistic about deploying AI workloads, especially inference engines on mainframe platforms. Steven, I know you have a lot of experience with mainframes and maybe even a little bias here and there, as previous segment kind of showed, but
me biased about mainframes? I don't know what you mean, Mike.
Let me write that down. What is it biased about mainframes? Okay, I got it.
There you go. But all joking aside, is the mainframe poised for some sort of renaissance in the AI era? Because, well, that is where all the data seems to be.
Well, it's an interesting one. I mean, we did some analysis and did some commissioned research earlier on this year, commissioned by Broadcom, 21CS and IBM. I just published a piece that compares that about against the work that Kyndryl did. A lot of similar findings. I think the key takeaway from our research was that it was no harder to find an AI specialist or a cybersecurity specialist than it was to find a mainframe specialist. There's various skills constraints in the industry that are just well known. The mainframe's one of those. It's not worse or better than any of the others. It's just one of those areas where there's not thousands and thousands of people like there would be Java programmers or web designers. It's one of those more edge case where you've got to think about skills programs. Lots of the vendors have been doing this for a long time. I think going back to your original point about AI, IBM made some announcements recently with its Telum 2 processor at Hot Chips. This is a 5 nanometer processor running at 5.5 gigahertz. Pretty cutting edge stuff. If Intel was to launch that, people would be interested. They also launched their new AI accelerator called Spire. Again, cutting-edge technology. We're going to see that come through in the new mainframe in 2025. So, hardcore chip innovation. IBM's got over 800 chip designers based in the Hudson Valley area doing cutting-edge design. IBM Research and Labs have done 2 nanometer technology. They've got on-chip water cooling. IBM's pushing the boundaries of this stuff. This is not legacy tech. If I told you that the first commercially available 7 nanometer based server was the IBM mainframe when they launched Z16, and that IBM beat Intel to market with 7 nanometer, that just completely blows up the narratives that they're legacy tech. So we have to put a pause on that. The piece, if you're going to do a fraud transaction in the credit card, actual credit card transaction loop, you can't be going out to the public cloud, doing a call on Gemini and then inserting that back. There's just too much round trip latency. So you've got to do those AI scoring, those fraud management, those KYC, AML, whatever the use case is, as close to the transaction as possible. You're going to be doing that on chip or reaching out to an accelerator that's actually in the machine. That's where IBM's going with this. They've got over 200 use cases for AI based on these transactional systems from the conversations I've had with them. So I think you've got to hold, going back to our previous conversation, you've got to hold 2 truths to be true at the same time. Public cloud can be growing, and hybrid cloud can be growing, and these infrastructures can be growing, and people can be putting AI again into those public clouds. And it can also be true that there's a scenario where you want to do AI in transaction at speed, at scale, on the mainframe. It's not either or. The way I describe it is boats, trains, planes, cars all exist because journeys are different, workloads are different, therefore they all need different chip architectures and underlying infrastructure to support them. So a long rambling answer, Mike, but yes, mainframes are cool for the transactional AI use cases.
Yeah, if I recall, didn't that survey say like 80% of the business leaders, it was a large percent of the business leaders were looking to incorporate AI into the mainframe.
Yeah, I mean, BMC's about to drop its annual survey results in a couple of weeks' time. They'll have asked questions. They've been doing that survey for, I think, 19 years. Maybe could be wrong. I think, as you say, two things can be true at the same time. Public cloud can be growing. Oracle announced earnings last week and told us that OCI is growing at 45%. And on-premise mission-critical infrastructure can be growing at the same time. IBM in its last earnings said that the mainframe sales grew by 8%. That's in the very end of an extended product cycle. So normally they're talking about decline by now. They've got a new system coming out next year. Normally we're in the back end of that cycle, and we're talking, the CFO saying it's a cyclical cycle. This is 8 to 12 quarters. We're in sort of quarter 10 of the cycle, and they're still posting growth. So two truths can be true at the same time. It's not an either or.
I think there's a lot of reasons why you want AI in the mainframe, but you have to look at the workload. You're probably not going to train ChatGPT 4.5 on the mainframe. You want massive farms of GPUs to do model training for things like that. But if you're doing machine learning inference with live data, that's happening right there, provided it's not, let's scan all the available transactions and look for patterns of fraud. No, you want to know, is this transaction a potential fraud? You've got a machine learning model and data that's already been analyzed. You can match that against. You want that to stay very, very high volume and stay close to where the rest of the transaction is happening. Maybe even for security reasons, you don't want it off memory, off chip from that machine. You don't want it to go anywhere else because it's very sensitive. Matter of fact, machines are being architected now so that the AI inferencing can happen in a certain part of the hardware that other memory areas can't get access to, et cetera, because of the security. Look at AWS's chip. They all are doing this. So there's a lot of good reasons why you want to do AI on the mainframe. Is a mainframe a great general purpose for model training? Some, but probably not for most. But tying it to transactions totally makes sense.
Highly tuned small language models, tight use case, not really generative. Absolutely. Sorry, Paul, you were going to say something and I jumped in front of you.
No, I was going to kind of echo in from the a couple of the comments that have been made on this so far. I would say, as we kind of tie the last segment into this segment as well, there's a number of things that are going on here in the that organizations take into consideration. One is historically, when mainframes came up, there was a central set of applications that were running on a mainframe, and the environments were far less complex than they are today. I mean, we just did evidence of what Mitch was just saying. There are certain use cases that mainframe is good for, and there's other use cases it's not. But that means that that organizations will have to add in additional resources to accommodate those use cases that don't have that's not good for the mainframe. But that adds complexity to the environment, right? That also adds a skill gap issue to the environment. You have this kind of bifurcated skill gap of organizations that are using their dare I say, heritage environments to run. They're working and operating seamlessly, but now we have to bring on new resources, new skill to kind of bridge that gap between the two. That's one thing. But the big factor that I think from the application side, especially as we start going to, releasing applications far more than what's been done historically. I mean, what we're seeing in our research, today, applications are being released at 2 to 3 times faster than just 3 years ago with the same or less resources to do so. So if that application growth is happening at that lift, one thing that mainframe does bring to the picture is consolidation and sustainability message as well. So you can consolidate down those applications to a more environmentally friendly environment for that infrastructure, but still accommodate your business needs of producing those applications as needed. So the challenge, complexity, skill gap, the use cases are there, but again, and I'm going to say this and Steven's going to, yell at me, but the underlying infrastructure really doesn't matter because whatever it's running on at the top, as long as it's meeting the business need, it meets all the different pieces, then it really doesn't matter. As long as the application teams are getting what they need.
I'm going to rename my podcast, Paul. Infrastructure doesn't matter.
No, it sort of matters. It matters sometimes.
It sort of matters. It's a catchy title.
I do want to ask Steven something here, though, that I think that I'm starting to see. Initially, all these AI projects were led by what you might call a tiger team. They had developers and data science and all these IT ops people, and they kind of operated in that fashion. I think to Mitch's point, as we run the inference engines more and more on these production environments, mainstream IT folks are going to start managing all of that as part of their function. And we'll see the data scientists focus on training, and there'll be separation of duties.
I think so. I mean, we're still really early. What are we, like 2 years into ChatGPT having changed our world? So the teams are starting to come out of POCs. They're starting to come into production use cases. The first of those applications are starting to come through into that cycle. If you've got a really tight, really sort of defined use case that's been through a testing cycle, and you're probably for the first time starting to deploy that into production in a place like a Citibank or a Wells Fargo or a Walmart. Maybe you've gone through that cycle faster if you're in a kind of fast-moving startup. But if you're moving that into production, from PO, like whiteboard, people staring at the universe, thinking about the first use case for AI, through into putting that in, we're probably only at the start of this journey. That application is going to look like any other application for a team to start to think about. How do we secure it? How do we back it up? How do we make sure it runs and operates? It's going to start getting passed over to the platform engineering team or the ops team at scale. So whether that's on the mainframe, whether that's on, Kubernetes running in Google Cloud, I would imagine we're only in the early days of those AI applications starting to be fully in production in big enterprises.
Mitch, you agree with that? Do you think that this is just going to wind up being, an extension of our DevOps workflows and MLOps and DevOps and feature stores and GitHub repositories and all that other stuff will just kind of meld together into one big happy workflow?
It has to be, but it won't necessarily one big happy journey. Because in the way you're talking about, Steven, by far, I don't have data to back this up, but I'm confident in saying the vast majority of AI being used today are machine learning algorithms and models, expert system models. Very little of it is a ChatGPT kind of LLM type applications. That's where we're in our infancy. When you're talking about feature stores, we've been in this era where the way the models, the way the algorithms, and the way the data is prepared for machine learning is on this own track where it goes through these cycles to develop the features, refine them to get the answers that we're looking for, based on the data, make sure the data is in representation that match the algorithms are optimized for that. And then we release the model. I think now we're in the era of how do we release that as part of our workflow? And call it a DevOps workflow, call it whatever you want, release cycle, whatever you want. It has its own, in some cases, its own meter and tempo. It takes its own different kind of work, but it's also integrated into the larger application, the fraud application we were talking about before. This is a fraudulent transaction. Well, I want to test my software, the app against the new model, the new algorithms for machine learning when that's ready to release. So make sure we're still in good shape. So I think the more, and there's activities that this is happening now where we can integrate machine learning and AI workflows into the overall DevOps workflow and understand where there are kind of in different fidelity of how processes work between software and AI models and be able to adapt to that.
All right, folks. So we have determined that mainframes still matter after 2 sessions. We'll be back in a minute.
Discover Techstrong Group, the epicenter of tech innovation. We're your go-to for reaching IT leaders and practitioners worldwide. Our secret? Impactful content that sparks awareness, engagement, and top-quality leads. With us, you'll access editorial websites, streaming videos, virtual events, custom content, analyst research, and more. Join our satisfied clients. Let's revolutionize your tech journey. Contact us today and tell your story to the world in the most powerful way with Techstrong Group.
All right, folks, we're back. And over on Techstrong TV a couple of days ago, we had an interview with Bill Lobink, who's over at IBM, talking about how FinOps needed to be embedded into the software engineering workflows. And it makes a lot of sense, but it seems to be one of those things that might be easier said than done. Mitchell, we've been letting developers provision stuff for years and never quite actually put any financial controls around it. It was kind of run after the fact. And in the last few years, we've seen the rise of FinOps. So is this a response to, I don't know, are developers kind of like drunken sailors just consuming everything there is out there and no adult supervision, or what?
It's like in music, 3 chords and a guitar, you got a song, you got a country song. Credit card in a browser, you got an application in the cloud. That's where we came from, in the cloud. And of course, once we realized how those costs roll up differently and aggregate differently, maybe I don't want that thing running all the time when I'm not using it. How do I bring it down? How do I automate that? So the FinOps has been catching up to what we're spending and controlling spend on the back end and moving it forward. I think where FinOps is best thought about is in the architecture of the application, the architecture of the infrastructure, and the entire kind of systemic view of how this is going to work, whether it's distributed or centralized or wherever that is, because then you can say, well, maybe I want to use Dynamo for my database, or maybe, no, in this case, I want to use Mongo because that's going to be more cost effective because it handles this differently. So that a lot of those cost decisions aren't just operational. They're also built into design, the architecture of the applications and assumptions that you make. And a lot of times as an architect, what you have to do is go create what I call architect prototypes. Let's go try this and see what kind of volume or what kind of a resource usage, if we take this approach or versus this approach. Okay, great. We figured that out. Now let's make sure when we deploy bigger parts of the application that still holds true. So I do agree. It's got to be part of it. If you don't, you got the wrong architect.
I think though, for FinOps to work well, it's going to take better communication. I think there's going to have to be a shift in companies, collaboration between all parties involved, and a different mindset from the engineers about cost.
Exactly. Paul and I are working on a total economic value sort of study as we speak around one of the big FinOps tools. So I think people process tools is the kind of simple rubric. That's where the majority of the cost savings are going to be. I think, Amanda, to pick up your point, you need to be thinking about the people side of this and how teams collaborate, how the dev team collaborates with the ops team, with infrastructure. And Paul, I'm going to pause it a minute because I can see you wanting to come in, but I think it's across the whole piece. Amanda, you nailed it.
Yeah, I think that, we're all touching on valid points here. One of the things that I often get into conversations with, whether it's advisory with clients or just the end users, CIOs and such, the biggest challenge with FinOps is, at least from the application side, is usually it's an afterthought. And it's an afterthought because the primary concern is the refactoring, or need to modernize, or I need to do something, right? And doing something was like, hey, we all high five. We did something. We refactored, and then to go, whoa, the costs are way out of control. Like, so now we have to figure out like what's the cost factor here. So when we talk to companies out there that are looking at FinOps solutions, right? And there's a number of them, obviously. I think 88 plus or something according to the FinOps.org, right? There
was 80 vendors at FinOps X. Right.
So those vendors that are out there, there's obviously a need in the market, but I believe, and this is the thing that I would advise anybody watching this video or anybody that's looking at new initiatives, is to obviously not just say, what's it going to cost, but put cost measures in place as you're going through the project. Because as you're doing the project, if you leave it up to, say DevOps teams, notoriously DevOps teams are going to over provision because they just need the resources that are needed to do the job. So as long as they have them, they're going to do it, right? But that's over provisioning. It's going to cost extra money. So understanding where the spend is going as you're implementing is probably the better approach than waiting until after the fact and then trying to scale it back from there.
I think, Paul, as if you're building a house, you have a certain budget you're working with, and you can design a kitchen that's 10x what your budget is by the materials you pick, the providers, et cetera. The same is true in software. It may not be for an individual developer. That's why I point to the architect. Someone has to look at the overall decisions you're making about how you are designing, constructing, and operating those applications, because those decisions drive up that cost or down.
Steven, how did we get here? Because back in the day, when we had those mainframes that you so lovingly tend to, we had capacity planning. We knew a lot more about the spending, and we paid a lot more attention to that. And then suddenly it seemed like the cloud came along, and we just forgot all those core skill sets.
I've got 4 teenage daughters, and they're wearing flared jeans. Fractions come back around, right? I mean, I think we're on a journey. What are we, 18, 19 years into the public cloud? Everybody ran and did what Mitch described with a credit card, shadow IT, spanned something up, and then realized it was expensive. And we're now just coming around the backside of that cycle with people going, it's now platform engineering is the phrase. I talk about sort of the grown-up ratio that I'm tracking, sort of the sports coat to hoodie ratio at some of these conferences. We're just getting to the point where this stuff started to mature. I think people are looking at their AWS, Google, and Microsoft Azure bills and going, this is the largest line item in my IT budget, therefore I need to optimize it. That's where the mainframe was 20, 30 years ago. It was the largest line item in people's IT budget, so they tried to optimize it. It's just fashion. It's what's old is new again, and we're just going through this cycle.
Paul, I think Steven is implying at least that developers are teenagers that can't be trusted with credit cards. So,
how did we get to that summation?
I think it's interesting. I mean, it's a dilemma that organizations run into quite frequently. Is if you're trying to meet your business KPIs of doing your agile sprint releases every 2 weeks, and you're trying to push code out the door, and there's barriers in the way, you can either do one or two things. You can put those checks and balances in place to slow the process down, which is going to slow down your business KPIs, or you can release the hounds and let them do what they want to do, which is going to overspend typically. But I think that you have to have those business KPIs aligned to the developer's expectations and vice versa, because I think that if you don't, then you end up having the challenge of you're not going to release your code on time or to your business KPIs. You're not going to have a successful team. I mean, if you're DevOps teams and developers need to be empowered to do their jobs, right? And if they don't have the tools to do their jobs, then they're stuck. There's so much on the developers now where they're sitting there with sitting with the catcher's mitt, everything's shifting left and being thrown to them. that, they need to be able to have a little bit of being fluid and dynamic and able to achieve their goals. If they have all the resources and tools they need, including the spending need to put in place, then that makes sense. But I definitely believe checks and balances need to be put in place. To Mitch's earlier point, you can design a kitchen however you want, right? You can design an application infrastructure however you want. It has to fit within the budget. And that budget needs to have those checks and balances.
All right. So, Mitch, Paul is insinuating that if I give teenagers credit cards with no limit, who's the fool? So,
I think I'm still stuck on Release the Hounds. That's an image I like.
I think Paul makes a really good point. It's about pragmatism. You want just enough friction with developers that they're being thoughtful about where they're deploying stuff and the cost. But you don't want too much friction because you don't want to slow them down and lose the benefits of turning applications faster and bringing things into production faster. The best organizations are making that trade-off and looking at that trade-off and going, infrastructure's got to be secure, it's got to be available, it's got to be the right price point depending on the type of application it is. So they're doing those things on one hand, but they're also thinking, how do I increase feature velocity, speed of application drops, get code into production faster? And those things pull people in two different ways. The best organizations are able to find that happy balance.
I think it's all on how you position it. If you pull the developers together and say, okay, we have to find a more cost-effective way. How could we reduce our costs here by 25%? Let's shoot for 50 and see if we can do that and go into a virtual room or a conference room and give them a problem to solve. They'll focus on that. If you go in and slap them down, because, you bozos, you hounds that are running rampant around here with our credit card, we're clamping down on you and we're taking the card keys away. And, you'll be lucky if we'll turn the lights on when you come in the building.
I think the term you're looking for is bad dog.
Bad dog. Exactly.
Amanda hits it perfectly, I think, a few moments ago. It's thinking about it holistically and it's thinking about it from a people perspective.
So, Steven, can I rely on the cloud service providers to give me accurate info that's useful for controlling costs? Do they have a vested interest in, helping those drunken sailors have another beer?
I think it's incentives. So the person trying to sell you something the best person to trust with how much it costs? I think you want an independent third party in that loop, whether that's a FinOps provider, whether that's a consultant or sort of optimization team you're working with. I don't think the incentive structure I'm going to pick on AWS. Turning around to AWS and going, I'd like to reduce my bill by 30%. Can we spin up a project where your salesperson gets less commission? Don't think the incentive structure for that works. Going to somebody like an IBM and Apptio and Cloudability and going, hey, IBM, I'd like to work with you to reduce my AWS bill. And a shared risk, shared reward project, where if you save me 30%, I'll buy some of your software, the incentive structure makes more sense. So I think if I was running a large enterprise, I'd probably have an AWS, a Google, and a Microsoft kind of engagement, going back to some of the stats that Paul mentioned earlier around hybrid and multi-cloud. I think I'd be looking at a separate cross-platform FinOps platform to reduce my costs on all three clouds. I don't think I'd be going to each particular cloud provider saying, hey, can you reduce your bill by 20%?
Amanda, do you think we might be able to use AI someday to just control these FinOps costs? And, I'll have all the data inputted in from these things through those lovely APIs we talked about earlier. And I will just throw that in a model and optimize it for controlling my costs.
Oh, yeah, absolutely. I mean, the use cases for AI, as fast as it's evolving, are growing by the day. So I'm sure that will be utilized.
All right. Mitch, that sound feasible to you?
It's a great machine learning opportunity because if you're doing FinOps as a service, right, through the cloud, like in many other types of applications or services, you have access to all that data that's being processed by each one of your customers. You can anonymize it and then look for patterns and do machine learning algorithms against it that you might not find in one customer looking at it yourself in our own usage of this particular cloud. But if I look over 100 or 1,000 different customers, you know what? We see some trends here and we can make some recommendations that will help you save money.
All right, folks, you heard it here. Hey, someday those AI models are going to be voice enabled, and when you overspend, they're going to say, bad hound. Hey, thanks for spending time with us, and we enjoyed the show today, and we invite you to check out the rest of the lineup that's coming up right behind us. Once again, thank you to our guests. We'll see some other folks tomorrow. Until then, we'll see you next time.
I'm Bonnie Schneider, sustainability contributor to the Techstrong Group. I'm excited to introduce you to a groundbreaking new initiative from Techstrong Research, the Sustainability Pulse Meter. The Pulse Meter offers valuable insights into how environmental responsibility factors into tech purchasing decisions for key players in the industry. Position your company as a leader in the industry and differentiate from your competitors with the Sustainability Pulse Meter, offered exclusively from Techstrong Research.